Alright, today we are doing section 3.2, transforming equations using multiplication and division. So our goal will be to solve equations using multiplication and division. Let's get through these warm-ups real quick. Notice that on the first two problems, we do not have an equals sign, so we're not solving, we're just simplifying. So on number one, we're just taking 3 times 4/3. Keon, what did you get?
Do we do the reciprocal?
We do not. We do not do the reciprocal. So we can treat this like 3/1 times 4/3. What would you get? 12/3, which simplifies to be what? 4/1, or we can just write 4. Okay, if there's not an equation, we don't have to do anything with the reciprocal. We'll talk about the reciprocal in a little bit today. Number 2, again, there is not an equals sign, so all we're doing is simplifying. 3t divided by 3. Shannon, what did you get?
1t.
1t, very good.
Can we just write t?
Yes, instead of writing 1t, you can just write a t. Number 3, this is like what we did yesterday. We have an equal sign already in the problem, so we need to get x by itself. Remember yesterday, we box the variable and draw a line through the equal sign. Jeriel, what would be our next step? Subtract 8. We do it to one side, we got to do it to the other side. And we get x equals negative 18, right? So when we see this, we lost 10, we lost 8 more. That means we lost a total of 18, negative 18. Alright, much like yesterday, we have a couple properties of equality. The first one is the multiplication property of equality. If a, b, and c are real numbers and a is equal to b, then a times c is equal to b times c. We can multiply both sides of an equation by the same thing. So we're going to do this example a little bit differently than what we did yesterday. No, we won't. We'll do it the same. Alright, so if a is equal to 2 and a is equal to b, then what does b have to equal? B is also 2. And they tell us that c is 6. So if we plug in a times c equals b times c, what do we get on both sides? 12. And yes, that is true. So it's fine to multiply both sides of an equation by the same number. Again, I don't think this is a new concept to any of us, but it's a skill we have to have, so here we go. The other property is the division property of equality. Again, a, b, and c are real numbers, and a is equal to b. Then we can take a divided by c, and that is the same as b divided by c. If a is equal to 8 and a is equal to b, then b is equal to 8. Okay. C is equal to 4, so we have 8 divided by 4 equals 8 divided by 4. What is 8 divided by 4? 2. 2 equals 2. That worked out. You can divide both sides of an equation by the same number. But there's something important we have to remember. The number 0 can never be on the bottom of a fraction. So how I was taught it when I was your age, or in high school, was to remember NO, no, and also OK. It's okay for 0 to be on the top. It is not okay. It's a big no for 0 to be in the denominator. Okay, so you might want to write down that little helpful hint to help you remember that. Alright, well, let's keep it going. We are going to start solving these. So I am going to do the same steps that we did yesterday, meaning I'm going to box in the variable and draw a line through my equal sign. Alright, when 8x is written right next to each other, Jaquan, what operation is happening between 8 and x? Multiplication. So when they're written right next to each other like that, we're multiplying. Deja, what's the opposite of multiplying? Dividing. So in order to reduce this to being just x, I'm going to divide both sides by 8. 8 divided by 8 reduces to 1, so I really am just left with 1x, or x. And then we have to take negative 756 divided by 8, which is when those calculators we're allowed to have come in handy. What do we get?
Negative 94.5.
Negative 94. You can put 0.5 or 1/2. Do we all agree? Those of us with calculators or that are really good at long division. Alright, and then we're done. Okay, and it's important to notice a negative divided by a positive came out to be negative. So we box in our answer and we are ready to move on. Once again, I like to box my variable. It's a little harder to do when we're multiplying. And split up the sides of my equation. May, what do you think I should do next?
Divide both sides by 5.
Beautiful. And what do we get when we do that?
15.
Perfect. A positive divided by a positive stays a positive, so we're just dividing. Alright, let's keep it going. Let's go on to example 3. Actually, I think I want to... Let's skip ahead to example 5, and we'll come back to example 3. On example 5. Nevaeh, what operation do we have going on between our variable and this 5?
Division.
Division, very good. So again, I box my variable, separate my equation. Natalie, how will I undo division?
Multiply it.
Multiplying. So I'll multiply both sides by what?
5.
Perfect. Alright, now on the left-hand side, this is kind of like a 5 over 1. Right? So these 5s just reduce out to being 1, which is how we're left with 1h. For some reason, I see students write it as 5h, and things just get weird. Okay, those 5s reduce or cancel to 1, so we're just left with 1h. And then we take 17 times 5,
85.
and we get 85. And that's all there is to it. Again, we're still remembering our rules about positives and negatives. Alright, so we backtracked to number 3. Kelby, what did your group get for number 3? What did you guys do? Negative 11. How did you come up with that? Divide both sides by negative 25. Wonderful. And you said that was negative 11. I like it. If you put negative 11 equals x, that's the same thing, as long as the negative sign is with the 11. All right, let's go on. Example 4. Danielle, what did your group do?
We divided by -4 on both sides.
Very good. I like it. What'd you get?
0.
Perfect. K equals 0, or 0 equals K. Remember, it is okay for 0 to be in the top. We just can't have it be in the bottom. Also, yesterday I had a student ask if they could just write K as the answer on a problem like this. The answer is no. I need to know what K equals. So even though it's a 0, we do actually write it this time. Thought that was an interesting question. All right, we did 5 together already, so we're going to skip on to number 6. Adrian, what did your group do?
Negative 16.
How did you get negative 16? Good. We multiply both sides by 2. So on the left, those reduce to 1. So we just have W. Negative 8 times 2 is negative 16. All right. Number 7. Again, I don't know why it printed that weird line there. So just kind of ignore that. Houston, what did your group do? Very good. And when we did that, what did you end up with? Beautiful. A equals negative 48. Okay, another thing we didn't really talk about yesterday, when you do write your answers, it should be the variable equals the number, or the number equals the variable. If you just write down a number, like if you were to just write negative 48 and circle it, that's not going to get you points on a quiz or a test. I didn't look too closely at your homework, but it looked like most people did it correctly. Just make sure you've got the whole thing down. All right, on to number 8. This one's a little tricky. Did any group think they got it? Keon?
X equals negative 14.
How'd you come up with that?
I multiply 7 times 2.
Well, if we multiply 7, positive 7 by positive 2, we'd get a positive 14. You what?
Negative.
Oh, by negative 2. All right. Yes, I would agree with that. This one's a little strange because we've got that negative out in front of the fraction. We want this side to end up being a positive u, so a negative times a negative is going to turn it positive. But then we need negative 2 times 7 is negative 14. Or again, if you like your variable on the left like I do, flip it around. Sounds good to me. Note, when a fraction is attached to a variable, just multiply by the reciprocal. Recall, a reciprocal or multiplicative inverse is two numbers whose product equals 1. I'm going to put my examples up at the top. Ooh, sorry. What would the reciprocal of 4/3 be? 3/4. We just flip it around. What about the reciprocal of 1/3? 3/1, or you could just write 3. What about the reciprocal of -5? negative 1/5. So it does not change whether it's positive or negative. Okay, so if it started positive, it stays positive. It started negative, it stays negative. We're just flipping it upside down. So if it starts off as a whole number or integer, you've got to know to put it over 1 and then flip it. Questions about reciprocals? Okay. Alright, so that note said that if we see a fraction attached to our variable, that we need to multiply both sides by the reciprocal of that fraction. So I've got my variable in a box. I split up my equation with a line. I see that I've got a fraction right next to my variable. It's attached to my variable. So I'm going to multiply both sides by what, Jaquan? Negative 7/2. If you want to keep the negative sign with the 2, that's fine. If you want to put it out in front, that's fine. Give it to the 7. Whatever it is you want to do, it's not going to make a difference in the end. To make my life a little bit easier, I could put this 14 over what number?
1.
A 1. Okay. Alright, on the left-hand side, a negative times a negative ends up being positive. Also, the 7's reduced to 1's. The 2's reduced to 1's. So I'm just left with what? 1a. 1a. And that's what I wanted. That was the goal all along. It was all reduced to 1's. We're just left with 1a. Well, the 14's negative and the 7's negative. Okay, so we have a negative times a negative. That gives us a positive. 14 times 7 is 98. 1 times 2 is 2. Do you think we're finished with this problem? No, because 98 divided by 2 is 49. So our final answer would be that A equals 49. We got to go all the way to the end. Now, if you have a calculator and you know how to type all this fractions and all that in, you can go straight to the answer. Most calculators will do that for you. I'm going to box in my variable, split up my equation. I see that I have a fraction attached to my variable. Jakeem, what do you think I need to do next? What is it? And we should keep it positive or negative? Negative 7/13. So I'm using parentheses to mean multiplication. If you don't like that, you can still use the dot. I just think it looks a little strange. But whatever makes you happy. The 39 can go over 1. On the left-hand side, a negative times a negative ends up positive. Those 7's reduced to 1's. The 13's reduced to 1's. So we're left with x. So the left side is just x. On the right, if you want, you can reduce before you multiply, or you can multiply and then reduce. Does anybody see what can reduce now as opposed to reducing later? No. May? Good. We can reduce across here, a numerator with a denominator. 13 goes into 39. So the 39 reduces to a 3. The 13 reduces to a 1. You do not have to do that first. You can reduce later. I just like to point it out for people who remember those skills. What do you do this in like 5th grade? Alright, so then we're left with 3 times negative 7. That's negative 21. Do I need to put it over 1? No, you can, but you don't have to. We can leave it right there. I box my variable. I split up my equation. Houston, what happens next? And what is that? Negative 10 over 1. When I go to the other side, do I need to put my negative 10 over 1? Do I need to put it over 1 here? Not really, right? Negative 10 over 1 is just negative 10. So if you want to put it over the 1, you can, but you don't have to, especially because the 5 is not written as a fraction. So I would just not. Again, we've done this a few times now. A negative times a negative is a positive. Negative times a negative is a positive, so those go to 1s. We're just left with R. 5 times negative 10 is negative 50. Again, that's why we didn't need to put it over 1, right? Negative 50 over 1, same thing. Alright, I kind of hate it when problems are set up like this because it makes it a little weird to show your work, but we're going to do our best. So I box in my variable, I split up my equation. Lexi, what should I do next? The reciprocal of 1/5 would be what? 5 over 1. So I'm multiplying this side by 5 over 1. Multiplying this side by 5 over 1. Or just 5. Right? 5 over 1 and 5 are the same thing. Now why I don't like this setup is because now my fraction and its reciprocal are separated from each other. But we just have to know that a fraction times its reciprocal is going to give us what number? 1. So we just have 1x there. And then on the left hand side, 5 times 25 is 125. So part of the reason why that works is that multiplication is commutative. So I can imagine that the 5 over 1 is right next to the 1/5. Remember, the opposite of x is written as negative x. And the opposite of negative 5 is positive 5. We have to remember what opposites are here. And here is why. On example 13, we have that negative x, or the opposite of x, is equal to 10. But we don't want the opposite of x, we just want regular old x. Does anyone think they know what x should be, Jaquan?
It should be just x, so you should times it by negative.
Good, so one way of doing these problems, usually you can either multiply or divide by a negative 1, it doesn't matter. If you divide both sides by a negative 1, this cancels to become a positive x. And 10 divided by negative 1 is negative 10. Basically, if you change the sign on one side, you have to change it on the other. So if we change negative x to a positive x, we have to change positive 10 to negative 10. Both sides' signs have to change. So I should have done my whole thing there. Alright. This one steps it up a notch. Again, when I box in my variable, I'm just boxing the variable. I don't want that negative sign next to it. So my goal is to get it all by itself. We have not done one like this before. Jamal, what do you think we should do first?
Multiply
No, I feel like we're going to have this discussion a lot this year. Not yet. What else is there to do?
Subtract 6.
Good. We usually do whatever's furthest away from the x or the variable first. So in this case, that would be subtracting the 6 to get rid of the plus 6. So we still have negative x is equal to, what's 4 minus 6? Negative 2. Again, I still just want plain old x. So now is when I switch my signs. So it would become a positive 2. If we change negative x to positive x, we change negative 2 to positive 2. We're almost through these examples. We got a lot of them today. So we have x, split it up. Jamarl, what do you think we should do first?
Subtract 21.
Very good. Subtract 21 from both sides. When we do that, we're just canceling out the 21 and the negative 21. That means there's still a minus or a negative sign right in front of x. 28 minus 21 is 7. But we don't want negative x, we want positive x. So we don't want positive 7, we want negative 7. Almost done. Lots and lots of examples today. Box in the variable, split up our equation. Adrian, what do you think we should do first?
Subtract about 18.
Very good. Subtract 18 on both sides. Again, we still have a negative in front of our x for now. 8 minus 18. Negative 10. Very good. Again, if you're not sure, get yourself a calculator. It'll come in handy. But we don't want negative x, we want positive x. So we don't want negative 10, we want positive 10. Again, if you rewrote it, x equals 10 instead, that works too. One more. Are we ready? All right. Last one. Same thing. Box my variable. Split my equation. Kelby, what should I do first? Or next? Subtract 7. Do it to one side. Do it to the other. 2 minus 7. Wonderful. But I don't want negative x. I want a positive x. So I don't want negative 5. I want positive 5. Okay. Lots and lots of examples.